Bismillahirrahmanirrahim. Today is the second or the last part of chapter 4, that is our chapter is regarding the tires. First, I will cover the quick recap and one or two clarification or the question asked. I will try to answer those, and then we will continue with our original lecture. First, a quick recap. This was the basic initial figure. Lot of information which is given on your side walls of your tire, the tire width, profile, aspect ratio, which type of tire it is, the inner dia of the wheel or tire or the rim dia, the load rating, the load and speed index. Then the detail of the side wall information, what all information is given on the tire, it is mentioned here. And three basic function, it supports the vertical load, develop longitudinal forces and develop lateral forces for cornering. Parts of tire, we have studied the tread, the main portion which is in contact with the surface, and this is the tread portion, and then the depth of the tread and the wear limits. Then further details of the tread area, the rib, the tread, the grooves and the sipes. Then further detail of the tread area. Then side walls, what all are written on the side wall we have already seen. And then the construction contain all the size and details. Then beads, the foundation of the tire is located where the tire grips the inside of the wheel rim. These are the beads which are in contact with your rim. Then we have a ply, body ply, we call it carcass. Plies depend, there are 2 or 4 or 6 or 8 number of plies depend on the types of tire which we are using. Then we have a belt. A tire belt is 2 or more layer applied over the plies under the tread portion. Material consists of steel, mesh, nylon, rayon, fiberglass and aramid. And these are the belts area under the tread area. Okay. Now tire construction, there are basic two types of tire construction. One is the radial one and second is the bias or diagonal bias. Radial construction, in which we have this type of a structure, and then we have belt arrangement here. The chord angle in the belt normally within 20 degree of the treads, basically used to stabilize and have a softer ride. Bias construction, in which the chord angle is high from 35 to 40 degree of the circumference. More good for the directional stability, but have some other advantages and disadvantages. Then the forces which are applying here, if we are moving in this direction from left to right, this is our leading edge and this is our trailing edge. Then we have a contact patch in this shape. Then size and load rating, the section height, the section width, the aspect ratio, the rim diameter, and how we in bias tire it is denoted like this, and radial tire it is denoted like this. Then this is the tire size designation, example given in the book. Question was there how this figures came. Now, theoretically speaking, we can go up to 20 plus 20 plus 20 for this plus 1 size and plus 2 size. Plus 1 size does not depend upon these side width or these aspect ratios. The plus 1 size means is we are going, if this was the original 15-inch inner dia of the wheel or the rim dia of the rim dia, then it's is a 50. We are going on plus 1. Then it means we are increasing 1 inch here. So the rim dia or the internal dia of the wheel is from 15 to 16 inch. It means plus 1. So it is basically the internal dia of the wheel or the rim dia of the wheel. So this is 16. If we say it's plus 2, then mean it original was 15 and plus 2 mean it is original and now it is 17. Now from going from original to plus 1 and plus 2, we have to keep one thing in mind. First we have to calculate the outside diameter of the complete wheel or the tire. First we have this inner dimensions, that is the rim dimension, that is the 15-inch. Then we have to calculate the sidewall height. Okay, we have given the width, we have given the aspect ratio, and this 154 will comes to width multiplied by the aspect ratio percentage. So 205 multiplied by 775 divided by 100, we will get 154 mm. So 154 mm here, 154 mm here. So the outer dia is 2 into this sidewall height plus the rim dia. So it comes out to be 27. Now we are going on a plus 1 size. So we know the dia from change from 15 to 16 inches. So the width of the side wall is going to reduce into be on the safe side in the, we have calculated the outer dia, that is 27 inches. So it should be below the 27 inches. So we will have like this. And when we are going for plus 2 size, the outer dia should be 27 inches. General rule is for every 10 mm increase in the tire width, the sidewall height needs to be reduced by 5%. Let's see this example. Now we are having this original size of 205 is the width, 75 is the aspect ratio, R is radial, and 15. Now we are increasing the width to 225 mm, means plus 20 mm we are increasing. Now current side wall height is equal to width into aspect ratio divided by 100. So we know the width is 205 multiplied by 75 divided by 100, we get 154. Now 154 plus 154 or 2 into 154 and plus the rim size, the 15, we get the outer dia. Now the new aspect ratio keeping the same side wall height. So new aspect ratio, same side wall height, new width into 10. So 154 divided by 225 into 100 approximately is equal to 68.4%. So thus the aspect ratio reduces from 75 to 68% when the width increases by 20 mm while keeping the outside diameter constant. So this is how the dimensions change when we are calculating from the original to plus 1 and plus 2. So same here. Now original width was 185 mm, the rim size was 15 inches. So this is the original size. Now we are going on plus 1. So we are adding plus 20 here. So 185 plus 20 means 205. So 16 inches here. And plus 2 plus 20 here further and plus 1 here. But practically speaking, we can go up till plus minus 10 mm. Okay. So we have already studied this, how much bigger I can go. So these are the figures which we have. This is the section width in millimeter. This is the aspect ratio. This is the construction type. Then we have the rim diameter in inches. This is the load index, and this is the speed rating, the thread area, the shoulder area, the side wall area, the lower side wall, the tubeless wall, the rim, the beads which attach with the rim, and radial plies and belt area. Speed index and load index we have studied. The load index is this figure, the numeric value. It corresponds to the on table the certain amount of kilograms it can withstand. So one tire withstand that much of a kilogram, then multiply by 4. That vehicle can withstand that much of a load. Speed rating alphabets denotes the speed rating. We have the speed rating. If H is the speed rating given, then the tire speed which can it goes to maximum is 130 miles per hour or 210 kilometer per hour. So these are the letters. Let's suppose we have this H, so it can goes up to 210. If it is a S, it can goes 180 kilometers per hour. So these are the corresponding values of these letters. What affects does the tire? So it affects the speedometer reading, odometer reading, and the fuel economy. Now, how to calculate the tire circumference, the speed of speed, and the speed miles per in miles per hour. So these are the formulas, and we have these are the further formulas, and we have solved this numerical in the last lecture. And these are the results of when we have a original size. Then we have to calculate for +1 and +2 theoretically, means we will go 20 mm plus 20 mm. Now this was the previous lecture. Now coming towards the lecture, the tire pressure and traction. All tires should be inflated to the specification given by a vehicle manufacturer. Most vehicles have recommended tire inflation figures written in the owner's manual or on a placard or a sticker on the door, post, or glove compartment. The pressure numbers molded into the sidewall of a tire should be considered the maximum pressure when the tire is cold. Pressures higher than that stated on the sidewall may be measured on a hot tire. I read again. All tires should be inflated to the specification given by the vehicle's manufacturer (OEM). Most vehicles have recommended tire inflation figures written in the owner's manual or on a placard or a sticker on the door, post, or a glove compartment. The pressure numbers molded into the side walls of the tire should be considered the maximum pressure when the tire is cold. Pressure higher than that stated on the side wall may be measured on the hot tires. Now, rim width and tire size. As a general rule, for a given rim width, it is best not to change tire width more than 10 mm, either wider or narrow. As a general rule, for a given rim, if we are using the same rim, the width we can go plus minus is that is 10 mm, either wider or narrow. If we do not change the rim, then we can only go plus minus 10 mm. For a given tire width, it is best not to vary rim width more than half an inches in either direction. For example, if the original tire size is 195/70 into 14, so the rim size is 14 and the width is 195 and the aspect ratio is 70, then either as 185/70 into 14 minus 10 mm or a 205/70 into 14 plus 10 mm could be used on the original rim wheel without undue harm if the replacement tire has a proper clearance with the body and the suspension component. If we are using the same original rim, we can go plus minus 10 mm in increase in the width or decrease in the width either way. Okay. But if we are going on a +1 or +2 size, that is a different story. We are changing the rim. So changing the rim means we are increasing the size to +1 means from 14 to we are going to 15 mm plus the width is increasing from 20 mm. Okay. Now, uniform tire quality grading system. The US Department of Transportation (DOT) and the National Highway Traffic Safety Administration developed a system of tire grading, the Uniform Tire Quality Grading System, to help customers better judge the relative performance of a tire. The three areas of tire performance are tread wear, traction, and temperature resistance as shown in this figure. As this is written as tread wear 300, traction A, temperature A. So few other information are written here. Dot B938 CTTX, and this thing 0401 means it was manufactured in 4th week of 2001, as you have seen in the video clip. So it is a tubeless. So let's see the tread wear 3300, sorry, tread wear 300, traction A, and temperature, what these thing means. All tires sold in the United States must be approved by the US Federal Department of Transportation. The tires code requirement include resistance to tire damage that could be caused by curb, chuck holes, and other common occurrences for a tire used on a public road. Let's suppose this it is written as 0605, means this tire was built in the 6th week of 2005. Tread wear. As we have seen, the tread wear here is 300. Let's see. The tread wear grade is a comparison rating based on the wear rate of a standardized tire tested under carefully controlled conditions, which is assigned a value of 100. A tire rated 200 should have a useful life twice as long as the standard tire. If your tire having a tread wear rating of 100, it can approximately covers 20,000 miles or 32,000 kilometers. If it is 150, then these are the. If it is 200, then twice the original values. Now, in our example, we have 300 value. So approximately it can cover 60,000 miles or 96,000 kilometers. So tread wears generally gives you a reference value that how much kilometer your tire can cover, okay, without the problem. If you are using in a controlled environment, or I can say if you are using in a appropriate environment. But if your driving habits or braking habits is not good, then this value may change. You may get your tire will be showing a tread wear 300, but you can have, if your driving habits is not good, your braking habits are not good, the road condition is not good, then you cannot go up till these limits. Okay. The tread wear life of any tire is affected by driving habits. Fast stops, starts, and cornering will decrease tread life. Tire rotation or lack of tire rotation, inflation, wheel alignment on road surfaces, and climate condition can affect your tread wearing. So these all factor affects your tread wearing. Second was the traction. Traction performance is rated by letter A, B, and C, with AA being the highest, as we have seen in the figure here. This traction is A. So AA being the highest, the traction rating is only one of many other factors that affect wet braking traction, including air inflation, tread depth, vehicle speed, and brake performance. So traction properties are defined by these letters, and double A means being the highest traction we get from this tire. And in our case, we have the A rating, so it is slightly less than double A, the highest traction rating. The traction rating is only one of the many other factors that affect wet braking traction, including air inflation, tread depth, vehicle speed, and brake performance. Now, the third was the temperature resistance. As we have seen here, temperature A. So let's see. Temperature resistance is rated by the letter A, B, and C, with A being the highest rating. So tire generates heat while rotating and flexing during normal driving condition, because the rubber is in contact with the metal road or the road surface, so heat is generated, so it has to bear that heat. So these are the letters which shows the category of tires A, B, and C, and A being the highest rating one. A certain amount of heat buildup is desirable because tire produces their highest coefficient of traction at normal operating temperatures. For example, race car drivers frequently swears their cars left and right during the pace laps, causing increased friction between the tire and the road surface, which warms their tire to operating temperature. However, if the temperature rises too much, a tire can start to come apart. The oil and the rubber in the tire start to become a liquid. Grade C is the minimum level that all tires must be able to pass under the current Federal Motor Vehicle Safety Standard 109. So these three are also important. First is the tread wear, then traction and temperature resistance. Now, this few slides, which I know I am going to cover, is from the book which is Fundamental of Vehicle Dynamics by Thomas D. Gillespie. Now let's talk about, we have studied the tires, all the information which is given on the tires, then what about tire changes, and now tire has to move. What all forces are there? Well, what all moments are there? Well, what all resistance are there? What are the forces acting on the tire? We have to see that. Now when I show this figure to my students, they all get confused and worried. Then I explain it is very simple. Let's see how it is very simple. First, let's draw this tire. We have drawn this tire, then we'll make it center. We have drawn the center. Now draw the planes, wheel planes or the tires plane. Normal plane is like this. We draw it like this. Then we have this dotted line. Okay. Then this line and this, and then in this plane. Okay. Now, due to steering geometry, the camber caster angle and the toe in toe out, it is not in this plane. So the tire is moving outward. So we have to draw the tire plane also. So this is this plane. Okay. Now there is angle gamma, that is your camber angle from the vertical line to the tires line. So this is the positive inclination angle gamma, the camber angle. Now, due to toe in and toe out, we and actual x-axis is in this direction and y-axis is in this direction and z-axis is in this direction. But due to toe in and toe out and caster and camber steering geometry, the direction of the wheel is like this. So the angle is the positive slip angle, alpha here. So we have made the wheel plane, the positive inclination angle, camber angle gamma, the positive slip angle, the direction of wheel. Now let's wheel plane, wheel center, center of the tire in contact. This is the center of the tire in contact with the road surface. Then the loaded radius from the center point till the point of contact with the road, that is your loaded radius. The longitudinal forces in the x direction. So this is your x direction of wheel heading. This is the tractive force Fx in x direction and moment, overturning moment mx, overturning moment mx. So longitudinal forces Fx and overturning moment mx. Now coming towards the lateral forces in y direction. So this is your y direction and the forces, lateral forces in y direction is your Fy and rolling resistance against the y-axis, that is your my. Rolling resistance moment in y-axis, so this is my. Now coming towards the normal forces, which is acting on the normal to the plane that is in z direction. So going downward, this is normal force Fz, and aligning torque mz in the z plane. So we have covered wheel plane. This is your wheel plane. Okay, wheel center, this plus sign, center of the tire contact to the ground here, loaded radius is here, longitudinal force in x direction, overturning moment mx, lateral force in y direction, then rolling resistance moment in y plane, then normal force in fz, and aligning torque in aligning moment in mz. And slip angle we have already covered in x, the difference between the direction of wheel heading to the direction of wheel travel, the alpha, and the positive inclination angle, the camber angle z. Now wheel plane, the central plane of the tire normal to the axis of the rotation, the wheel center, intersection of the spin axis and the wheel plane, center of tire contact, intersection of the wheel plane and the projection of the spin axis onto the road plane, loaded radius, distance from the center of the tire contact to the wheel center and the wheel plane. So this is your, as I explained, the wheel plane, x and z. Wheel center is this plus sign, then center of the tire contact to the road surface is this one, and the loaded radius from this center point to the here. Now the longitudinal forces Fx, component of the forces acting on the tire by the load in a plane of the road and parallel to the intersection of the wheel plane with the road plane. The force component in the direction of the wheel travel, sine component of the lateral force plus cosine component of the longitudinal force is called tractive force. So this in x direction we have this tractive force Fx. This is the longitudinal force. Lateral forces Fy. Component of the forces acting on the tire by the road in a plane of the road and normal to the intersection of the wheel plane with the road plane. So in y direction, this is your spin action, the wheel torque. So rolling resistance moment, this is your lateral forces. Normal forces which is acting normal to the plane. Component of the forces acting to the tire by the road which is normal to the plane of the road. The normal forces is negative in magnitude. The term vertical load is defined as the negative of the normal force and thus is positive in magnitude. So vertical load is defined as the negative of the normal force and is thus positive in magnitude. Then we have overturning moment, mx, moment acting on the tire by the road in the plane of the road and parallel to the intersection of the wheel plane with the road plane in x direction. Rolling resistance moment, my, moment acting on the tire by the road in a plane of a road and normal to the intersection, not parallel, normal to the intersection of the wheel plane with the road plane. Aligning moment or the torque moment, moment acting on the tire by the road which is normal to the plane of the road. And slip angle, the alpha, angle between the direction of the wheel heading and the direction of travel. Angle between the direction of the wheel heading and the direction of the travel. Positive slip angle correspond to a tire moving to the right as it advances in the forward direction. Camber angle, angle between the wheel plane and the vertical. Positive camber corresponds to the top of the tire leaned outward from the vehicle. If it is leaned inward, then it is a negative camber. Now, the mechanics of forces generation. See the figure here. Tire is moving in a clockwise direction. So first, this part will come in contact with the road while it is moving, and this is your trailing. This is the leading edge, this is the trailing edge. It is rolling in this direction. The pressure forces, the stationary forces will be like this pressure distribution under a rolling and non-rolling tire. The forces on a tire are not applied at a point, but are the resultant from normal and shear stresses distributed in the contact patch. So this is the contact patch. So we have the resultant of normal and shear stresses distributed in this contact patch. The pressure distribution under a tire is not uniform. The pressure distribution under the tire is not uniform, but will vary in the X and Y direction. But will vary in X and Y direction. When rolling, it is generally not symmetrical about the y-axis, but tends to be higher in the forward region of the contact patch. So when rolling, it is generally not symmetrical about the y-axis, but it tends to be higher in the forward region of the contact patch. Because of the tire's viscoelasticity deformation in the leading portion, this is the leading portion of the contact patch, causes the vertical pressure to be shifted forward. So this is how the mechanics of forces is generated in the tire while rolling. The centroid of the vertical forces do not passes through the spin axis. So this is the spin axis. The centroid of the forces of the vertical forces do not passes through the spin axis and therefore generates rolling resistance with the tire rolling on a road. Both tractive and lateral forces are deployed by shear mechanism. So we have both tractive and lateral forces are developed by a shear mechanism. Each element of the tire tread passing through the tire contact patch exerts a shear stress which is integrated over the contact area is equal to the tractive and or lateral forces developed by the tire. So we have to integrate it to the whole area, which is of the contact area. Now, friction coupling between the tires and the road. Surface adhesion. Surface adhesion arises from the intermolecular bonds between the rubber and the aggregates on the road surface. So this is your road surface, this is the rubber. So there is a surface adhesion between them. The adhesion component is larger of the two mechanism on a dry road. Out is reduced substantially when the road surface is contaminated with water, hence the loss of friction on water road. So if there is some water, we have a loss of traction, loss of friction. So surface adhesion is more on a dry road. The hysteresis mechanism represents energy losses in the rubber as it deforms when sliding over an aggregate in the road. Hysteresis and adhesion. The hysteresis mechanism represents energy losses in the rubber as it deforms when sliding over the aggregate in the road. Hysteresis friction is not so affected by the water on the road surfaces, thus better wet traction is achieved with tires that have high hysteresis rubber in the tread. So tires with having a high stresses rubber, road traction achieves better as compared to the other tires on a wet traction. Tractive properties. Now let's see this figure. This is the contact length, which or the contact patch or the contact area in contact with the surface. This is a travel direction. So first this come in contact and this is the leading edge and this is the trailing edge. The vertical load will be like this with your x-axis. The friction forces will be like this and the relative slips will be like this, breaking deformation in a contact patch. Under acceleration and braking, additional slip is observed as a result of deformation of the rubber elements in the tire tread as they deflected to develop and sustain the friction forces. So these are the forces which develop in tread while acceleration, braking, and additional slip. Now there is another term known as ply steer. Ply stir is another term that describes slight pulling forces on a vehicle due to tire construction. Now, this portion of a presentation or the slides or the lecture is from your main book, The Automotive Technology by James D. Alderman. The ply stir is another term that describes the slight pulling force on a vehicle due to tire construction. Ply stir is due to the angle of the cord in the belt layer. So the ply stir is due to the angle of the cord in the belt layer. In radial tire, it is up till 20, and in bias tire, it is from 35 to 40 degree. As seen in the figure, this one, figure 109, notice the angle of the belt material in this worn tire. The angle of the belt fabric can cause a ply stir or a slight pulling force towards one side of the wheel. This is not in the ply layer of the carcass body as the main name implies. Ply stir will cause a slight drift regardless of its direction of rotation. Switching tires left to right will not correct a ply stir condition. Ply stir is built into the tire during construction. There is nothing a service technician can do to correct ply stir except to compensate for it with wheel alignment. Remember one thing, when you have to replace the tire, following important factors must be done there. First is the balancing of the wheel. You have to balance the wheel on a machine. So we apply some weights to balance along with its rim. Then we have to do the alignment. Wheel balancing and wheel alignment are the two important things when you have to replace or change the tire. Now, cornering properties. So direction of heading is this and direction of travel is this. The angle between them is, we already know that is slip angle. This is the slip region. This is the contact patch. And the pneumatic trail is the forces are acting in this direction. So one of the very important function of a tire is to develop the lateral forces necessary to control the direction of the vehicle, generate lateral acceleration in corners, means turning, or for lane changes, and resist external forces such as wind, gust, and road cross slope. So lateral forces are required to be developed because of the cornering, acceleration, changing lane, and to cater for the external forces to resist the external forces such as wind, gust, and road cross slopes. These forces are generated either by lateral slip of the tire, slip angle, or by lateral inclination, camber angle, or combination of these two. So these slip angle and camber angle are helpful in producing the forces which are cater for the lateral slip. Cornering, handling on a turn, or you make say sharp curve turn on the track by little oversteering, which is necessary to overcome centrifugal cornering forces, is called cornering. So your tire should not leave the ground in any case while turning. So lateral forces has to be developed to balance this uplifting of the tire. Now, nitrogen inflation. We have to fill the air in the tires, but some shops recommend and inflates tire using nitrogen instead of using compressed air. Why so? Compressed air contains about 78% of nitrogen and 21% of oxygen and 1% of other gases. If air already contains mostly nitrogen, why use pure nitrogen? There are several reasons included. Because air already included 78% of the nitrogen. So why we are using pure nitrogen? So reasons are the nitrogen molecule is slightly larger than the oxygen molecule, so the tire will lose pressure faster if air is used instead of nitrogen. Nitrogen molecule is slightly larger in size as compared to the oxygen molecule, so it will the oxygen will lose pressure faster as compared to the nitrogen. Compressed nitrogen contains less moisture than compressed air. The second factor is, first was the molecular size of the nitrogen. Second is the less moisture in nitrogen, compressed nitrogen as compared to the compressed air. When the tire heats up, moisture in the tire vaporizes and expands, causing the pressure inside the tire to increase. Even small changes in the tire pressure can noticeably affect the handling of the vehicle. If your tire pressure is not correct, it will affect your steering, handling, and your ride. So the compressed nitrogen contains less moisture as compared to the compressed air. When you are using extremely using moving the vehicle, tire heats up, the moisture in the tire vaporizes and expands, causing the pressure inside the tire to increase. Even small changes in the tire pressure can noticeably affect the handling of the vehicle. Some oxygen in the tires could, over a long period of time, causes the oxidation of the inner liner of the tire and the corrosion of the wheel. So as compared to nitrogen, oxygen has the property of oxidation. So oxidation leads to the corrosion as compared to the compressed nitrogen. So race teams also most use nitrogen use nitrogen as compared to the oxygen. So whenever you want to change your tire, must fill your tire with your nitrogen, compressed nitrogen. It will long last effect on your tire life also. Tire rotation. To ensure long life and even tire wear, tire rotation is essential. It is important to rotate each tire to another location. Very important factor for the life of the tire. Some rear wheel vehicles, for example, may show premature tire wear on the front tires. The wear usually starts on the outer tread row. This wear usually appear as the front to back, high and low wear pattern on individual tread blocks. These blocks of tread rubber are deformed during cornering, stopping, and turning. This type of tread block wear can cause tire noise and/or tire roughness. While some shoulder wear on the front tire is normal, it can be reduced by proper inflation, alignment, and tire rotation. For best results, tires should be rotated every 6,000 miles or every 6 months. Tire rotation is a maintenance phenomena. We have to rotate the tire from one location to another for after 600 miles or after every 6 months. So the how in which manner or which pattern you can tire rotate. Let's see the front wheel driven vehicle. This is your front. So the front tire goes to the rear, front right goes to the rear right, front left goes to the rear left, and rear left goes to the front right, and rear right goes to the front left. This is called at modified X or preferred method. Or rear wheel drive method, the rear left goes to the front left, the rear right goes to the front right, and the front both wheels goes to the alternate. The front right will go to the rear left, and the front left will go to the rear right. So this is called as modified X or preferred method. Now, if we have a front or rear wheel drive, full X means front right, rear left, front left, rear right. So we change like this. Or front or rear wheel drive, front or rear acceptable. Front goes to the rear and rear goes to the front, and rear goes to the front and front goes to the rear. The method most often recommended is the modified X method. This one. Using this method, each tire eventually is used at each of the four wheel locations. An easy way to remember the sequence, whether front wheel drive or rear wheel drive, is to say yourself, drive wheels, straight cross, or the non-drive wheels. So this preferred method is X method is used because in this type of method, a tire will change to all the location as compared to this acceptable or this type of method. Now this type slide shows the assignment which I normally give to my student. There are basically four questions. First one is define run flat tires. If we see, go to your book, the the main book, this one. This is the chapter which I have covered from the book. And if your tires has written this LT, ML, MH, ST, or this is LT is for light truck, ML is for mining and lodging, MH is mobile home, ST is for special trailer, and TR for truck. And these are the cross-reference charts, load index. These are the letters corresponding to the speed. And if your tire is having this E number, E code, these E1, E2, E3, then it is corresponds to that country. Okay. We can use that. And this is the load index table, means 95. 95 means it can withstand 690 kg or that much of a pound. This E2 depicts France. Then we have the slip angle, the tire tread bearing, traction, and run flat tires. Run flat tires are designed to operate without any air for a limited distance, usually 50 miles at 55 miles per hour. This features allows vehicles manufacturer to build vehicle without the extra room and weight of a spare tire and jack assemblies. Basically, there are different types of run flat tires. Run flat tires are where we do not used air, or maybe we have solid rubber tires. So this is the explanation of this. Now, beside the tires, on the tires, where else the tire pressure is written or mentioned in the car or Jeep, I have already covered this part in my lecture, that it is on the side of your door pillars. Now, why tires are always black in color? Because of the chemical carbon black which you use during the manufacturing process. The color is black. We can have in different colors, but we generally used is the carbon black chemical which is used in the manufacturing. The fourth question, which is very interesting, which I give to my student, is that which type of tire your instructor vehicle have. So you have to go to the instructor vehicle and to make a selfie along with the tire, and then write all the description on the side wall. Take a picture and write all the information which is written there on the side wall and explain. So this is the assignment which I gave to my student, and do consult the book which I am referring, the Automotive Technology by James D. Elderman, and the Fundamental Principle of the Vehicle Dynamics by Jason Gillespie. Thank you very much for joining. I hope you are getting something from my lecture. Thank you very much.